Very warm good evening to all design aspirants. Our we are back with our series of number systems. So in our yesterday's session, we had a discussion about few questions of that are frequently asked in NIFT exams. So today again we are continuing from there. That is Today again we are continuing from there. That is, we'll be talking about few more types of questions that are frequently asked under the heading of number systems. Before we start, let me welcome you all once again on the behalf of entire Creative Edge team. So if you are new to our YouTube channel, please I request you to subscribe our channel for the regular updates related to all design and architecture entrance exams. And also, follow us on Instagram and Telegram for regular updates related to all design and architecture entrance exams. If you are looking for free study material to download, you can download the study material by clicking on the link given in the description box. So, all my design aspirants who are specifically targeting NIFT 2023, let's continue our session on number systems, and this is number systems part 2. So, let's solve few questions. Let's learn few more concepts of number systems. So the very first question is, it reads, how many vectors does 1200 contains? Right. So it is number of factors. We need to determine number of factors. So the process for determining number of factors is to divide the given number into powers of prime numbers. Right. So I have split this 1200 as 12 into 100. Further, this 12 into 100 can be broken as 4 into 3 into this 100 can be broken as 10 into 10. This 100 can be broken as 10 into 10. As I've told you, we need to convert this into prime number. So that will be 2 to the power 2. This is already a prime number. This again 2 into 5 and whole square because 2 into 5 into 2 into 5. So we'll have 2 to the power 4 into 3 to the power 1 into 5 to the power 2. And to determine total number of factors, we add 1 to each of the prime numbers power. So that is 4 plus 1 into 1 plus 1 into 2 plus 1. Right. So that gives us 5 into 2 into 3. So the total number of factors of 1200 will be 30. Next we have what is the unit digit of given number. So for this we need to know the digit cycle of each number. Say here we have 7, and if you take 7 to the power 1, you get unit digit as 7. If you have 7 to the power 2, you'll have 9 as the unit digit. So this 7 must be at the units place. We are talking about the 7 being at unit place, right? And we are talking about the unit digit value. So 7 at unit place, third power you'll have 3 at unit place, and 7 at unit place with power 4 you'll have 1 at unit place. After this, it will again start from here. That is 7 to the power 5 will have 7, 7 to the power 6 will have 9, 7 to the power 7 will have 3, 7 to the power 8 will have 1. So what do? We divide this 750 by 4 and check how much of the component is completely divisible by 4. So what we find out is 748 is divisible, and we are left with two powers, that is 7 into 2. 687 into 2 and 687 to the power 748. And this 687 to the power 4 to the power 1. So right, 4 ones are 4, carry over is 3, 3, 4, 34, 8 times, then 7 times. So for these many times, this cycle gets repeated, and then we'll have 7 to the power 2, that is 49. So unit digit is 9. So for this part, you'll have unit digit as 1. So 1 into 9 will be giving us 9. So result to the given question will be 9. I hope it is clear to you all. let's look at the next one. When 17 to the power 400 is divided by 18, find the remainder. So we apply the rule x to the power n minus x a to the power n. When this factor is is this power is even, when this power is even, right? When x minus a to the power n and this n is even, it is divisible by x plus a, right? So here this is even and this x is 17, so 17 plus 1 is divisible and the remainder will be 1 and the remainder will be 1. This is the standard rule. If you are not able to understand this standard rule, let me help you out with one more example, right? If you write this 17 to the power 2 and then rewrite it as this way, so this 17 to the power 2 is 289 and try to divide this 289 by 18. 18 ones are 18, carry over is 10 and 9. So 109. 18 6 are 108. So the difference is of 1, right? So for every second power of 17, you will have a remainder 1 for and then you can substitute that value as here. So 1 raised to the power 200 or 1 raised to the power anything will give you result as 1. So remainder here will be 1. Next we have what is the remainder when 4 to the power 5000 is divisible is divided or is divided by 7, right? So again I'll be writing this 4 to the power 5000 as 4 to the power 3 into some component and the remaining part, right? So I'll be dividing this 5000. Why I am dividing it as 4 to the power 3? Because 4 to the power 3 is 64 and when I divide this 64 by 7, I'll have remainder 1. So what do we do in this remainder part is we try to convert it into power remainder of plus 1 or minus 1 so that we can we can reach to the conclusion easily as we know power of 1 is always 1. If for minus 1, the negative 1, if it is an odd power, result will be minus 1. And if it is an even power, the result will be plus 1. So that ways we can calculate the remainder easily. That's why we try to convert given number in such a manner that that whenever the divisor divides the given number, it gives you a remainder of plus 1 or minus 1. So let's consider it. Thus 5000 when divided by 3, you'll have 3 ones are 3, remainder as 2, 0, 6 times. Again 2, 0, 6 times. And at the last, once again, we'll have this and remainder 2, right? So we'll have 4 to the power 3 and whole to the power 166 into 4 to the power 2. Right. For this much part, we'll have remainder 1, and for this part, that is 4 to the power 2, we'll have 16. So when 16 is divided by 7, we'll have a remainder of 2. So the answer to this one is 2. The answer to this one is 2. Next, we have 19 to the power 5 plus 21 to the power 5 is divisible by. So see, unit digit of 9 to the power 5. 9 to the power 1 gives you 9. 9 to the power 2 gives you 1 as unit digit. 9 to the power 3 will be giving you 9. 9 to the power 4 giving you 1. 9 to the power 5 will be giving you unit digit as 9. So unit digit for 19 to the power 5 will be 9 and unit digit for 21 to the power 5 will be 1. So the resultant is 0. So it is definitely divisible by 10. Also, if we add 21 and 9, if we add 21 and 9, if we add 21 and 19, we'll have 40, which is divisible by 20. So answer to this one is both 10 and 20. Next, we have how many figures or digits are required to number a book containing 190 pages. So, to give a number from 1 to 9, we need 9 digits. To give a number from 10 to 99, we'll be requiring 99 minus 10, that is 89 into 2, right? So 2 nines are 18, 2 eights are 16 plus 1, 17. So already we require 9 digits for this single digit and 178 digits for this double digit. And then from 100 till 190, the result will be 190 minus 100, that is that is 90 into 3, so that will be 270. So 270 plus 9 plus 8, right? But in this case, we need to convert this because also if you are doing this 89 and 90, you are committing an error because when you subtract 10 from 99, you leave this 10, right? That is also two-digit number. So whenever you need to determine this value, you should keep this in mind that whatever is the smallest number, subtract a number less than that. So 99 minus, look here, 9 minus 1 would have been 8, but we have considered it as 9 minus 0 here. So 9 minus 0 giving you 9, 99 minus 9 giving you 90 into 2, 180. Let me write it slightly here. So 9 minus 0 giving you 9 into 1, that is 9. 90 into 2 giving you 180. And here 190 minus 99 giving you 91 into 3. So 3 ones are 3, 9 threes are 27. So 273 plus 9, 282, 282 plus 180. 282 plus 180. So 288, 16, 213, 14, 462 will be the answer. So as I have told you, don't commit this error of subtracting 99 minus 10 or 190 minus 100. If you do so, you'll end up marking wrong answer. So make sure you follow this correctly whenever you have to determine the number of digits required, right? Next, we have sum of all natural numbers from 70 to 97. There are two ways to solve it. One is uh, take a sum from 1 to 97, then take a sum from 1 to 70 and take the difference of both, right? Not exactly 70, but 1 to 69 because you have to consider this 70 as well, right? The other one is go by arithmetic progression approach that the first term is given to you, the last term is given to you, and the common difference is 1 because you need to determine sum of all natural numbers and the difference between any two consecutive natural numbers is 1, right? So let me solve it both methods. So method 1, n into n plus 1 by 2. So 97 into 98 by 2. So this is 97. This 97 can be rewritten as 100 minus 3 into 49. So 4900 minus 150 minus 3, that is 147. So 4900 minus 100, 4800. 4800 minus 40 is 4760. 4760 minus 7 is 4753. Right. So now from this part, we will be subtracting n into n plus 1 by 2. That is keeping n equal to 97, keeping n equal to 69 here. So that will be 69 into 70 by 2. So that is 35. Or I can say 70 minus 1 into 35. 7 5 is a 35, 7 3 is a 21 plus 3 24, 240, 2450 minus 35. That will be 2415. So subtract this 2415, 2415. 13 minus 5 is 8, 4 minus 1 is 3, 7 minus 4 is 3, and 4 minus 2 is 2. 2338. So answer should be option C. Now let's talk about the method 2. Method 2. That is using arithmetic progression. So here A is equal to 70, common difference is 1, and Tn, last term, is 97. So Tn 97, 97 is equal to 70 plus n minus 1 into 1. So 97 minus 7 is 27, 27 upon 1 is equal to n minus 1, or n is equal to 28. So put this value in the formula, Sn is equals to n by 2 into A plus Tn. That is 28 upon 2 into 70 plus 97. Let me continue here. So this is 14 into 97 plus 70, 97 plus 300, 100 plus 67. So 167. So 14 sevens are 98. Carryover is 9. 14 six are 84. 84 plus 10, 94 minus 1. So 93. Carryover is 9. 14 ones are 14 plus 9, 23. So 2338. Both ways you will have option C as the answer. Next we have, on Children's Day, sweets were to be equally distributed among 250 children, but on that particular day, 50 children remained absent. Hence, each child got one extra sweet. How many sweets were distributed? So let's say X number of sweets were distributed among 250 children. Then X plus 1, right? X plus 1 divided by 200. This would be equal to 1 because each child got one more extra sweet. So 250, 50 children remain absent. So present were 200. So take LCM of the two. So LCM will be 500. So this is 5x. This is 5x. 200 into 2. So this is x. This should be x plus 1. X plus 1 upon 200 minus x upon 250. Originally this much, additionally this much. So difference of the two. So taking LCM, 200 and 250 will be 1000. So this is 5 times. So this is 5x plus 5 minus 4x. So this is x equals to 1000. If you are not able to understand this ways, let me explain the conventional basic approach. Let x be the number of total sweets, total sweets, right? If this x were divided among 250 children, there would be some value. And if this x be divided among 200 children, then there will be some value. And definitely this number will be larger than this number. So this difference is equal to 1. It is given that each child got one extra, right? So now taking LCM, 1000, so 200 into 5, so 5x minus 250 into 4, 4x equal to 1. So that gives you x equal to 1 into 1000. So x equal to 1000. Answer to this one is 1000. Next we have the digit in unit place of the product, this and this. So again, this is a case of digit cycle. For 3 to the power 1, we get unit digit as 3, 3 to the power 2, we get unit digit as 9, 3 to the power 3, we get 7 as unit digit, 3 to the power 4, we get 1 as the unit digit, and again 3 to the power 5, we come back here. And for 2 to the power 1, we get 2, for 2 to the power 2, we get 4, for 2 to the power 3, we get 8 as unit digit, and 2 to the power 4, we get 6 as unit digit. Again, we come back here. So divide this by 4. So 4 4s are 16, 2153 to the power 4 to the power 4 4s are 16, 4 1s are 4 into 2153 to the power 3. This is how we can divide this one part, and this 212 to the power 124 further completely divisible by 2. 212 to the power 4, 4 3s are 12, 4 1s are 4. So for this part, you'll have 6 as the unit digit. And for this part, this is 1 here. And for the power 3 part, you'll have 7 here. So 7 into 6, 7 into 6, 42. Unit digit will be 2. So final answer will be 2. Next, and the last one for the day is 3 to the power 25 plus 3 to the power 26 plus 3 to the power 27 plus 3 to the power 28 is divisible by which of the following? So take 3 to the power 25 common, then you'll have 1 plus 3 to the power 1 plus 3 raised to the power 2 plus 3 raised to the power 3. Let's substitute these values. This is 1 plus 3 plus 9 plus 27. 27 plus 9, 36 plus 3, 39 plus 1, 40. So 3 raised to the power 25 into 40. So this number is always divisible by 40. Also, every power has a 3. So 3 into 40 is 120. So the number is divisible by 120. And this almost covers all the possible varieties of the number systems. And thank you for being there. Thank you for listening patiently. And please subscribe to our channel if you have already not subscribed to our channel. And also follow us on Telegram and Instagram for regular updates and additional content related to all design and architecture entrance exams. So thank you guys. Thank you for being there. See you in our next session.